Okay, next up, we're going to talk about how to find the holes in the function. So to do that, the first thing you have to do is factor. I've already done that for this problem. The second thing we're going to do is we think about for the holes, there's two parts that we have to find. Okay, so for any holes in the function, I need to know two parts. I need to know the x-intercept, the x-coordinate and the y-coordinate. The x-coordinate is tied to any giant ones that you might have in your expression. The y-coordinate, we're just going to plug in the x-coordinate. Okay, so the first thing I've got to do is figure out where are the giant ones in this function. Well, giant ones are usually pretty easy to identify, but this is one that always tends to get people. It's right here, x over x. Just x over x, not x over 3x. It's just the x over x that gives you a giant 1. So what I do is I figure out what the coordinates of the hole in the function are by doing two things. The first is to find the x-coordinate. I take the factor that forms the giant 1, and I set it equal to 0. And that's going to give me my x-coordinate. So the factor that forms the giant 1 is just x. So I set that equal to 0. Now what's nice about that is I don't have to do anything to solve for it. It's just 0. If it had been something else, like x minus 2, then I would have to solve for x by adding 2 to both sides, and I would have gotten 2 as my x-coordinate. Second step is to take that x-coordinate and plug it back into our function. But this is where you need to be really careful. We need to actually simplify that giant 1 before we can do this. So I'm going to write that just down here. The simplified version of our function ends up being x minus 4 times x minus 1 over 3 times x minus 3. So what I'm going to do, I'm going to star this one, is to find the y-coordinate, I'm going to plug in the x-coordinate I just found into the starred version of my function. So I'm going to plug 0 into that starred form of the function. So I'm going to get 0 minus 4 times 0 minus 1 over 3 times 0 minus 3, which ends up being negative 4 times negative 1 over 3 times negative 3. And that's going to give you 4 over negative 9, or negative 4/9. Now I want to keep going with this because I just want to show you how this is tied to your domain. But before I can do that, we have to talk about any asymptotes, or vertical asymptotes. So let's talk about vertical asymptotes for a second. Vertical asymptotes are tied to the denominator after you factor and reduce. So after we get rid of any giant ones. So in this case, and I'm going to go to the next slide, to figure out the vertical asymptotes, I'm going to take any factors in the denominator and figure out what would make those factors 0. In other words, what's going to make my denominator 0, which causes my function to be undefined. That's where my vertical asymptotes are going to be, because that's going to indicate those places where my function doesn't work, where that x value doesn't work. So to find my vertical asymptotes, I'm literally going to take each factor that I see in the denominator and set it equal to 0. And then I solve. 3 can never be 0. So this first one just doesn't give us anything. But x minus 3, if we add 3 to both sides, we get x equals 3. So there's two pieces of information here that are really important. Our vertical asymptote and the x-coordinate of the hole in the function, because those two things tell us the x values that can't be included in our domain. So just like we talked about with end behavior, if you know the slant or horizontal asymptote, you don't need to know the equation and you don't need to see the picture to write the end behavior. The same thing is true for your domain. Domain comes from, it comes from any vertical asymptotes and holes in your function. And I'm just going to put in parentheses the x-coordinate only. And here's what I know. Those two values, and I'm going to put them in order from smallest to largest, are 0 and 3. Those two values tell me where the breaks in my domain will be. So when I go to start writing the domain, I always start out the same way. I start from negative infinity, and I say, okay, everything is good until I hit that first undefined value. Now, that undefined value is either going to be from a hole or from a vertical asymptote. And the first one I come across is 0. All right, now I know that I can't include 0, so that's why we have the parentheses and the union symbol in between the two portions of our domain. So then I say, okay, well, we pick up from 0, and we're good until we hit that second undefined value, which is representing our vertical asymptote. And then I know that we're good after that until forever then, because there's no other values, there's no other x values that we can't include in our domain. Okay, I hope that helped. So that's just a little bit on how you do vertical asymptotes, holes, and domain, and how they're all related.